Alrighty, let's get into IPsec. Alright, so it's an industry standard, so it's got an RFC there, RFC 2401, describes IPsec, providing data security and integrity services, works at the IP layer, and supports unicast and multicast traffic. Okay, so back to the previous slide. Okay, so IPsec VPNs consist of two major steps. There is a tunnel establishment, establish a secure tunnel and parameters that define secure traffic. You can do it manually, or you can do it dynamically using IKE, which stands for Internet Key Exchange. IKE. Typically, you use IKE. So that is the first phase, which really is usually the IKE phase. And then there's the IPsec traffic processing, which takes traffic between the two tunnel endpoints by using security parameters defined in the tunnel establishment step. So the first step, we set up the parameters, and the second step is we're going to use those parameters. Okay, so it is a two-step process as we're looking at here. So tunnel establishment establishes a secure tunnel that defines the traffic, and the IKE process here provides increased functionality in secure environments. It uses UDP, port 500. We're going to set up our security parameters using this phase. So we're setting up what's known as security associations. We're going to use these parameters in our second step when we go and create our IPsec tunnel. Negotiates what's called proposals containing encryption and authentication algorithms. Okay, so the two ends are really agreeing on things like the shared numbers. Okay, so we talked about in our key exchange process, we talked about there are certain things which are shared at both ends. We talked about, in our example, we said there was this number which we represented by P, and then there was a base number as well. So these two things have to be agreed upon and shared. So these things are negotiated between the two ends. We will then create the encryption and authentication keys automatically. We provide the ability to rekey frequently. What does that mean? Rekey frequently. What that means is that we're going to go through the Diffie-Hellman key exchange process. We're going to create this key for our symmetric encryption, but we're not just going to do it once. We're going to do that every now and then. We're going to do that periodically so that we change the encryption key, okay, so that it becomes absolutely impossible to receive the data or capture that data and then figure out what the encryption key was. Okay? Just the computing power it takes to do that, it just makes it impractical, for one thing, and the fact that we're going to change the key anyway every now and then, that just makes it impossible. So it also provides gateway identity functions. So we have our part of our authentication process in here as well. This is the IKE. So we create these things called security associations, where the different parameters of our IPsec communication are agreed on. A security association is identified within the device using this SPI, which is an internal index number. It has a destination address and it has a security protocol. It's the IKE, and there are two different security associations. There is the IKE security association and the IPsec security association. IKE is established during IKE, which is known as phase 1. And the IPsec is established during the IKE Phase 2 negotiations. So we have a security association database. So every VPN that is established has this security association associated with it. Okay, so what's in this database? So we would have a name of the VPN. It'll have an IP address. It's going to have this number, this SPI number of the local and the SPI number of the remote device. It'll have a security protocol. It'll have an encryption algorithm that is agreed upon. In this case, it's 3 DARES, but it could have been AES just as easily. We've got an encryption key, and we've got our hashing algorithm, SHA in this case, and we've got an authentication key. Okay, so that is an example of a security association database. Excuse me. And you can see we've got one at each end, and they correspond to each other. Okay, so we've got the other ends. So we've got a name. We've got the other ends gateway address. The protocols have to be the same. The encryption algorithms have to be the same. Encryption keys will be the same, as will the authentication keys. Okay, so the phases are tunnel establishment, phase 1. 2 peers will establish a secure authentication channel with which to communicate. The DH key exchange algorithm is used to generate a symmetric key common to the communication pathways. Main mode is used when both tunnel peers have a static IP address, and aggressive mode is used when one tunnel peer has a dynamically assigned IP address. You get to choose the mode. Typically, you will use main mode when you are setting up a VPN between 2 sites. The IPsec security associations are negotiated using phase 1, secure channel. Proxy ID is used to identify which security association is referenced for the VPN. With the help of key exchange algorithm can be used again to create PFS. Now PFS stands for Perfect Forwarding Security. So you can go through the process again. So what's happening is we're setting up this. We're setting up our encryption keys in phase 1. You can go through the process again and exchange the information in encrypted form to create a new key. Phase 2 is known as quick mode. So phase 1 main mode, process, have a message, SA proposal list. Proposal list is accepted. The DH public value A and DH public value B, and message 5 is this is where we're actually hashing. Identification, we have a hash key, and those keys are exchanged. That's phase 1. Aggressive mode, fairly similar. And phase 2. Okay, so what's happening here is the 2 devices at each end are exchanging information and essentially negotiating the parameters of the communication. That's probably the thing to take away from this. Then the IPsec tunnel process protects traffic between the 2 tunnel endpoints using the security parameters defined in the previous step. Okay. So IPsec modes, we've got transport mode and we've got tunnel mode. and the protocols are AH and ESP. So there's a couple of different modes and a couple of different protocols that can be used with IPsec. To give you an example of this shortly, we're going to take a look at a IPsec tunnel that's we've got running. So we've got transport mode, we've got tunnel mode, a couple of different modes. The same modes are selected at each end. Two different protocols in transport or tunnel modes, AH and ESP. The main point is you choose which one you're going to use, and it has to be the same at each end. So usually we're going to be choosing ESP. That's our standard one that we normally use. Okay, so tunnel mode packets and ESP packets. I think the main takeaway from this is you're going to be choosing ESP unless you have a good reason to do something different. Okay, traffic processing is we've got our two endpoints there. We are going to be putting our prefix, interface, and our gateway ID together. We're going from zone private to zone public. Then we've got our security association. We've got our source address, destination address, which is included in that security association. We've got our application equals any, and then use tunnel. We then have our hash, which is applied to that. We then end up with our final packet. So there's our hashed packet. We have that our SPI applied to that, which is our security association indexed. Encapsulation, ESP, encryption, in this case is AES, authentication, SHA. Right, so it's important to recognize when you see AES to know, okay, that is a symmetric encryption algorithm. When you see SHA to know, oh, okay, that is a hashing algorithm. What is AES doing? AES is providing confidentiality, it's encrypting. What is SHA doing? SHA is providing integrity to ensure that my message hasn't changed. Okay, so IPsec summary is we've got phase 1. With our header, we're going to create a security association. We're going to use the diffie-Hellman key exchange to create a session key. In phase 2, we're going to use our security association, I think, for a proxy ID to set up our encryption for phase 2. And then we'll create our tunnel across which our data will pass. Okay, how do we configure? Let's get into actually configuring the VPNs. So there are two different ways we can do it, route-based and policy-based. What does that mean? Well, these are the mechanisms which we're going to use to direct traffic into our VPN. How do we decide, or how do we say what traffic goes into a VPN? Well, we can use a policy, and we can set up some matching criteria on a policy. We can say anything that matches this particular policy, we're going to direct that traffic into a VPN. Or alternatively, we can set up a route-based VPN. We can say any traffic that is destined for this particular network is going to be directed into a VPN. So the route-based is probably a little bit more common, because if we're saying, well, we're going to be sending traffic from site A to site B, the networks that we have at site B V's. Therefore, any traffic that is destined for site B will have to go into the VPN in order to get there. And so that would be set up on site A, and of course the corresponding would be set up on site B, so direct traffic going from site B to site A. So the route base is probably a little more common, but there will be circumstances where maybe the policy base will be more suitable. Okay, are you understanding the difference between the two? Okay, the purpose of the route base or the policy base is the mechanism we're going to use to direct traffic into the VPN. Okay, elements of IPsec VPN configuration. So we have got the IKE phase 1, IKE phase 2, and then we've got the IPsec implementation method of either policy-based or route-based. So that's what we're going to do. Let's get into this configuration. Configuring the IKE phase 1 proposal. So it is done under the security IKE hierarchy. We are going to set up a name for the proposal. We're going to give it a user-defined name. We're going to set up the authentication method. We're going to set up our pre-shared keys, and we're going to set up our RSA signatures. We're going to choose a DH group, either group 1, group 2, or group 5. We're going to choose an authentication algorithm, either MD5, SHA-256, or SHA-1. We're going to set up an encryption algorithm, which could be 3DES CBC, could be AES 128 CBC, could be AES 192 CBC, could be AES 256 CBC, or DES CBC. Those are our choices. Now, the main point is that you choose about the same thing at both ends. And we're going to set up the lifetime. In other words, how often are we going to generate a new pre-shared key? How often are we going to generate a new key for our symmetric encryption, which is known as a session key? How long does our key last for? And it's in seconds. So we could generate a new one every 5 minutes, whatever suits us. Now, to make your life slightly easier, there are some Junos predefined setups here. In other words, instead of you going through and saying, gee, what key shall I choose? What group shall I choose? What authentication algorithm shall I choose? What encryption algorithm shall I choose? There are some preset choices in there. And if you went to each end of your VPN and chose the same presets, then your job is done. So we have got basic, compatible, and standard in there. Step B, configuring IKE phase 1 policies and reference the IKE proposal. So we've set up, let's go back to step A. So we've set up the proposal. Now we're going to set up some policies and we're going to reference the proposal. So the main, the mode, is it main or is it aggressive? Generally you're going to choose main. What proposal are we using? You're going to give it a name. Now you could go and choose one of these proposal sets that are already pre-configured. That just makes life easy. If you do go and choose one of the pre-configured sets, that means that you don't. That means that you can skip step A because that's already done for you. That's done. You just go into step B and you say, oh, I'm going to choose this one or that one, whatever it is. You then have to put in your pre-shared key. That is then generally just put in ASCII text. That is a plain text pre-shared key. Okay, so that is part of the Diffie-Hellman key exchange stuff. This is the stuff that is going across the channel. That's equivalent to the value P in our example. We looked at previously. We're looking at the Diffie-Hellman key exchange. That's our pre-shared key. Okay, step C, configuring IKE phase 1 gateway and reference the IKE policy, which we set up in step B. So under the edit security IKE, we're going to set up a gateway, give it a name. reference the policy name. We have an address here of the other end. That's the other end of our connection. We have an external interface, which is our interface on our device, and dead peer detection, where we can say, when are we going to decide that the other end of the connection is dead? In other words, we've lost connectivity. So the reason we need that is so that if the other end is dead, we actually stop sending traffic down to the other end. Okay, so we say, well, if we don't get anything from the other end in a certain number of seconds, or we're going to try and see if the other end is alive every certain number of seconds, and then if we don't hear from the other end after, so let's just say our interval was, I don't know, say it was 5 seconds, and our threshold was, say, 3. Well, every 5 seconds we're going to see if the other end is alive. If we don't hear from it after 15 seconds, well, we're going to decide it's dead. That's dead peer detection. Okay, so this is our phase 2, IKE phase 2. We're under the security IPsec this time. Okay, so previously we were under IKE, now we are under security IPsec. Proposal name, referencing the proposal, we're going to either say AH or ESP, most likely ESP. Authentication algorithm, encryption algorithm, lifetime in either kilobytes or in seconds, and we can use these predefined proposals again if you wish, or we can use the proposal that we define right back in the very first step. Step B, configure the IKE phase 2 policies and reference the IKE proposal. So we are still under security IPsec right here. I'll give you an example of this working shortly. And configure the IKE phase 2 VPN tunnel and reference the IKE phase 2 policy, which we configure in step B. Is there. And this is for the route-based. We have to reference this interface, bind interface ST0. Now, ST0 is a logical interface which is predefined within the operating system. So you don't have to define it. It's already created within the GNOS operating system. All you have to do is reference it under your VPN and use the bind interface configuration parameter for that particular interface. Okay, we then reference the IKE, gateway name, and the policy name. If you're using manual keys, you'd use that, but you probably aren't. You're probably using IKE. And then you can decide, am I going to establish tunnels immediately, or do I establish the tunnel when I've got traffic for the tunnel? The usual thing is you establish the tunnel immediately, so your tunnel comes up straight away. The benefit of that is you want to know, really, is my VPN up? Okay, so generally you put establish tunnels immediately. So that was the route-based phase. Now we can go ahead and apply the VPN from the security policy, where we're going to direct traffic into the VPN based on a match criteria. So we could say if the traffic is coming, if the traffic is matches source address, destination address, application, then permit and direct it into an IPsec VPN. And the route-based is we are going to be defining the interface. We're going to have to give it an IP address as usual. You may want to set the MTU size there to suit what your VPN can take. We've already looked at the bind interface parameter, and what is important here is that we go in and we set a static route. This is really important, a static route to the networks at the other end of the VPN, so that when traffic is destined for those networks, the next hop becomes our ST interface, which we have previously configured. And one very important step which you must not forget is you must put the ST interface into a zone. Otherwise, no traffic can go through that VPN. Which zone do you put it into? Well, you put it into the same zone that your internet connection is in. Okay? Because that's where your traffic is going out through. How do we monitor a VPN? Make sure that it is in fact working. So there are tunnels here. So looking at these, let's look at this example first. Let's work through this example. So, okay, let's look at this example. So here's our example. We've got a private network there on 10.1.10.5 and a private network on the other end at 222.1. Looks like. So we have got from zone to zone, we've got a policy VPN-A, we've got some matching criteria there, then permit tunnel IPsec VPN. So we're using a policy to direct traffic into our tunnel, and we're using a policy at the other end to direct traffic into the tunnel, traffic that's going the other direction. This is an example of the actual configuration for that scenario where we're setting up our proposal. We are then setting up our IKE policy, we're just calling it IKE policy 1. We're setting up our gateway where we're pointing our traffic to the other end, which is that 11701. Let's go back to the slide here. I just want you to take note. That is the public IP address of the other end of the connection. Okay, so the address that goes here is the public IP address of the other end. So we have dead peer, we have our external interface using that. Again, referencing the proposal, choosing authentication, encryption. These parameters have to be identical on both ends. So the authentication algorithm, the encryption algorithm, and the lifetime in seconds must be identical. For using perfect forward secrecy, the key group must be identical on both ends. VPN tunnel A, so we're just referencing our gateway and referencing our policy. We're establishing tunnels immediately in this case. Alright, monitoring the VPN, the command show security IKE security associations will bring up our security association with IKE, and the show security IPsec security associations will bring up our IPsec security associations. If we go show security IPsec statistics, we'll see the traffic that has been going through our VPN. Okay, this is a route-based VPN. Looked at the previous one was a policy-based VPN. So with this one, we are setting up. We've got a static route next to 1.1.80.1. We're setting up our interface, which is ST0, giving it an IP address, and that is the 1.1.80.2/28. I'll give you an example of a route-based one. We'll go through that shortly. That's our interface that we have configured. IKE phase 1 parameters, and that's our binding our interface into our tunnel, and that's the verification of that route-based VPN. Also, the benefit of a route-based is we can actually go in and look at the interface itself, the ST0 interface, and we can take a look at the traffic that's been going through the interface. That's it. Okay. So what I might do now is I might just show you an example of the configuration of a route-based IPsec VPN, and then we'll go in and we'll verify it and see if it's working and see what we've actually got. Okay, let's jump into this particular session here. Here we go. Log in as me. Alrighty, so let's go and look at the configuration to start with. Back up there. As security IKE, that's our first spot. Let's take a look at what's under there. So first of all, we've got a proposal. My proposal name is home. I'll give you a clue to where that's going. Pre-shared key, that's my pre-shared key. I've got an inactive policy here, which I can probably get rid of. I have got a gateway, also called home. It references my policy up here. So there's, if you go right up to the top here, let's start off. So there's my proposal. Okay, so I've created a proposal called home. Let's probably start there. Authentication method is pre-shared keys. DH group, we're using group 5. Authentication algorithm, we're using SHA-256. And encryption algorithm, we're using AES-256-CBC. And the lifetime in seconds is 28800. So that is my proposal parameters. I then go into my policy where I reference my proposal and I put in my pre-shared key. Now you can't read it, that's been encrypted in the configuration, but when you enter it in plain text. Jump down to our gateway. The gateway references the proposal there, it references my policy as well. IKE policy is home, the address. This address here, that is the public address of the other end of my VPN. So that is the public address that the device at the other end is attached to. We've got a dead peer detection, interval is 60, threshold is 5. So if I don't hear from the other end after 5 minutes, we're going to decide that it is dead. The external interface. So this is the external interface that the traffic is leaving from, is actually PP0. Now you might recognize that as the interface used to configure PPPoE encapsulation. And the version, this is another little thing I've added here, version 2 only. There is IKE version 1 and IKE version 2. What I've said is I'm only going to accept version 2. So that means that the other end has to be using version 2. Okay, so I've got another inactive gateway here. We don't need to look at that because we're not using any of that. Okay, I'll probably get rid of that. So that was my IKE. That was my IKE. In fact, I can probably just get rid of these things that I'm not using at some point. Okay, let's go and take a look at, let's go up, and let's take a look at IPsec. Let's see what's under there. So here's my IPsec configuration. We've got our protocol using ESP, authentication algorithm, which is HMAC SHA-196, encryption algorithm AES 128 CBC, lifetime in seconds is 1800 in this case. Policy was home. I am using perfect forward secrecy. I'm using keys group 5 in that case. Proposal was home, which just references my previous proposal. And VPN is home. I'm binding my interface. This is a route-based VPN. My parameters, my gateway is home, and there's my IPsec policy. Establish tunnels immediately. All right, so that's the configuration for my VPN. What I'm going to do is let's just jump out of there, and let's go and check if this is up. I'm going to do show security. I want to do my IKE security associations. Okay, so these are my security associations. We can see that this VPN has been up and down quite a bit in actual fact. Might actually be down. It was up at that point at least. Let's see what else we've got here. You can see this has changed, right? It's currently up, I think. Oops. It's jumping around all over the place. One of the things about these site-to-site VPNs is that they totally rely on your internet connections and the ability of your service provider to give you a reliable connection at each end. So that is actually the remote address. We go back and look at that in my configuration. That is the public address of the other end of my connection. And whenever it goes up, it actually comes up with the right address. But it is struggling a little here. It is struggling to get this this connection up. Anyway, there it is. Seems to be up at this point. All good. Let's go and look at the IPsec security associations. And we see that we do in fact have our connection up here. So we've got using ESP, and these are our protocols, and our connection is up. So that's looking good. Let's take a look at other monitoring that we can look at here. Let's look at our stats. Okay, so this is our stats. We can take a look at encrypted bytes, decrypted bytes, encrypted packets, etc. We'll take a look at any errors that we may have. Okay, let's take a look at show route oops, protocol static. What I want you to notice here with my static routes, apart from the fact that I've got my default static route, which you would expect, that is of course pointing out to my internet gateway, but here's the one that relates to my VPN. It's this one here. Okay, so what I'm saying is that traffic that matches 10.10.20.0/24 should be directed into this ST0.0 interface. Okay, so this is a route-based VPN. So that traffic is heading for that end. If I was to just ping, see if this will work, 10.10.20.1. Let's see if we can get a response from that. Maybe I can't. Maybe I can't actually ping that address. That may be the issue. Probably can't. I probably can't ping that address. If I can ping anything back there, probably not. Okay, I guess I'm just not accepting pings. But essentially, we do have our VPN up, and any traffic that is destined for that VPN will be directed into that VPN via ST0.0. Okay, so that's our working VPN. I notice I've got a few security associations in there that I don't really need. So if I wanted to clean that up, I would have to go into edit security IPsec. Let's take a look at that. See, I've got this inactive policy there. Let's see if I can get rid of it. Inactive VP, oops, N. Can I delete that? Let's see if I can delete that. I didn't like it. Let's see what I can do there. What can I delete? I can delete that. DYN. Delete that. Okay, that's good. So that was just getting rid of a VPN that I didn't need. Now I'm going to go up and get rid of that policy that related to that VPN. And what policies do I have there? I have got this one, IPsec. I'll get rid of that policy. That looks better. Let's do a commit check, make sure it's happy with that. Yep, that's good. We'll commit those changes. So now what I need to do, if I really want to get rid of this altogether, is go up to my IKE and take a look at stuff in there that I wasn't using. So I've got this gateway that I have got set up there. So what if we were to delete that gateway? And the one I don't want is this dynamic VPN. Let's get rid of that. So that's gone, and let's get rid of this policy while we're there. And it's the student VPN. Don't worry, I'm not deleting the student VPN. I I just haven't got it configured on this device. Okay, so that looks a whole lot better. To look at the IKE security associations. Looks like my VPN is currently down. One of the things that you'll notice with these site-to-site VPNs, they can be very, very unreliable. And in this case, it is down. Okay, so last time we checked it was up, and now it's down. Now this is just something that happens with these VPNs. They tend to be fairly intermittent, and that just goes back to show you the advantages of a carrier-based VPN, where you've actually got your carrier involved in implementing this VPN. It will come up again eventually, but it may take a little time. Well, it's not very happy at the moment. Well, it's found the other end, but no, it is down. Anyway, so that's VPNs. So we've had a look at VPNs. We've had a look at how to create them. We've had a look at route-based. We've had a look at policy-based VPNs. We've taken a look at the Diffie-Hellman key exchange process. We've looked at the concepts of confidentiality through encryption, integrity through hashing, and authentication through using a asymmetric encryption, actually encrypting our hash and decrypting our hash at the other end. Alrighty, so at that point we'll take a break and we'll come back and resume or get into our next topic after lunch.